Explain electrochemical cell and derive Nernst equation. An electrochemical cell is a device that converts chemical energy into electrical energy through redox reactions. It consists of two half cells connected by a salt bridge. Oxidation occurs at anode and reduction occurs at cathode. The potential difference between the two electrodes is called electromotive force, EMF of the cell. Under standard conditions, 1 molar concentration, 1 atm pressure and 298 Kelvin. The cell potential is called standard EMF, E0. For a general reaction, AA plus BB is equal to CC plus DD. The electrode potential under non-standard condition is given by the Nernst equation. E is equal to E0 minus 0.0591 divided by N log products divided by reactants, where N is the number of electrons transferred. The Nernst equation shows that electrode potential depends upon concentration of reactants and products. It is widely used to calculate cell potential, equilibrium constant, and pH of the solutions. Explain reference electrodes, standard hydrogen electrode, and Calomel electrode. A reference electrode is an electrode having stable and non-potential used to measure unknown electrode potentials. The standard hydrogen electrode, She, is the primary reference electrode. It consists of a platinum electrode coated with platinum black immersed in 1 molar H plus solution, while hydrogen gas is bubbled at 1 atm pressure. Its standard potential is taken as 0 volts. Though accurate, it is difficult to maintain. The Calomel electrode is a secondary reference electrode. It consists of mercury in contact with mercurous chloride Hg2Cl2 and saturated potassium chloride solution. It is more convenient and stable than She and commonly used in laboratories for potential measurement. Explain construction and working of glass electrode for pH measurement. The glass electrode is an important ion selective electrode used for measuring pH. It consists of a tin glass bulb filled with a known concentration of HCl solution and an internal Hg or HgCl reference electrode. The glass membrane is sensitive to hydrogen ions. When the electrode is dipped into a test solution, the hydrogen ions exchange with metal ions present in the glass membrane, producing a potential difference across the membrane. This potential depends on hydrogen ion concentration and follows the Nernst equation. E is equal to E0 minus 0.0591 pH. Thus, by measuring the potential difference, the pH of the solution is determined accurately. It is widely used due to its simplicity, quick response, and accuracy. Explain electrochemical corrosion mechanism in acidic and alkaline medium. Electrochemical corrosion is a deterioration of a metal due to electrochemical reactions occurring on its surface. It involves formation of anodic and cathodic areas of the metallic surface. In acidic medium, iron undergoes oxidation at the anode. Fe gives Fe2 plus 2 electron. At the cathode, hydrogen ions are reduced. 2H plus 2 electron gives H2. In alkaline or neutral medium, oxygen participates in reduction. O2 plus 2H2O plus 4 electron gives 4OH minus. The ferrous ions react with hydroxide ions to form hydrated ferric oxide Fe2O3 XH2O, commonly known as rust. Thus, corrosion is essentially a redox process involving metal oxidation. Explain cathodic protection methods. Cathodic protection is a method used to prevent corrosion by converting the metal surface into a cathode. Since corrosion occurs at the anode, making the structure cathodic prevents its oxidation. In a sacrificial anode method, a more reactive metal such as magnesium or zinc is attached to the ion structure. The reactive metal acts as an anode and corrodes instead of ion. In the impressed current method, an external DC power supply forces the structure to act as cathode. Both methods are widely used in underground pipelines storage tanks, and ship hulls.
Classify nanomaterials and explain their synthesis methods. Nanomaterials are materials having particle size between 1 and 100 nanometers. Due to their small size, they exhibit unique physical, chemical, and electrical properties. Based on dimension, nanomaterials are classified as zero-dimensional quantum dots, one-dimensional nanotubes, two-dimensional graphene sheets, and three-dimensional bulk nanomaterials. Nanomaterials are synthesized by top-down and bottom-up approaches. Important methods include sol-gel method, where a colloidal solution, sol, is converted into a gel and then heated to obtain nanoparticles, and a chemical reduction method, where metal salts are reduced to form nanoparticles. These materials are widely used in electronics, sensors, and catalysis. Explain carbon nanotubes, structure, properties, and applications. Carbon nanotubes (CNTs) are cylindrical nanostructures formed by rolling graphene sheets. They are of two types: single-walled CNT and multi-walled CNT. CNTs possesses extraordinary mechanical strength, high electrical conductivity, and excellent thermal stability due to strong carbon-carbon bonding. They have very high tensile strength and low density, and making them lightweight and strong. CNTs are used in nanoelectronics, field emission devices, supercapacitors, sensors, and composite materials due to their remarkable electrical and mechanical properties. Explain conducting polymers with examples. Conducting polymers are organic polymers capable of conducting electricity due to their presence of conjugated double bonds in their structure. The overlapping of pi electrons allows charge mobility along the polymer chain. Important examples include polyaniline and polypyrrole. These polymers are synthesized by oxidative polymerization of their respective monomers. Conducting polymers are lightweight, flexible, and corrosion resistant. They are widely used in batteries, sensors, anti-static coatings, and electromagnetic shield materials. Explain construction and working of OLED. An organic light emitting diode, OLED, is a light emitting device that uses organic materials to produce light when electric current passes through it. It consists of a transparent substrate, an anode, usually ITO, organic emissive layers, and a cathode. When a voltage is applied, electrons are injected from the cathode and holes from the anode into the organic layer. These charges recombine to form excitons, releasing energy in the form of light. OLEDs are thin, lightweight, flexible, and consume less power. They are widely used in mobile screens and television displays. Explain dye-synthesized solar cell (DSSC). A dye-synthesized solar cell is a low-cost photovoltaic device that converts sunlight into electrical energy. It consists of a transparent conducting oxide glass apparatus TiO2 semiconductor layer coated with dye molecules, an electrolyte, and a counter electrode. When sunlight falls on the dye, electrons get excited and are injected into a conduction band of TiO2. These electrons move through the external circuit producing current. The electrolyte regenerates the dye molecules, completing the cycle. DSSCs are inexpensive, easy to fabricate, and work efficiently even in low light conditions.